All right, guys, so we stopped off here yesterday with 40 through 50. So are there any questions on 40 through 50 that we didn't cover that you guys want to look at? So 40 or 41? 41. So when we look at this here, we really want to see if we can get the bases to be the same. If we can get 51 and, or not 51, 512 and 1/8 to be the same number. Because if we can get both of these to be the same number, it's going to work out a little bit better. Now, it'd be nice if they worked out to both be 8. And it does work out that 512 is 8 to the third. And 1/8, I can move the 8 to the numerator, making the exponent negative. Giving us this here. Now, if you ended up using 2 instead of 8, that's perfectly fine. It'll actually give you the same answer. So I would distribute first and then set them equal to each other. Because we have 8, 3 times 5x would be 15x, minus 3 is equal to 8. Distribute the negative 1, and we'd have x plus 4. We'd make both of those positive. And I just put the x first because that's just dealer's choice. Bless you. Bless you. It really doesn't matter what order we put them in, but I like having the variable first. Now, because the bases are the same, we can set the exponents equal to each other. So 5x minus 3 is equal to x plus 4. Now we need to solve for the value of x. Exactly, we would minus x from both sides, which will tell us that 14x minus 3 is equal to 4. Then we would add 3 to both sides, which would tell us that 14x is equal to 14, yes. And last but not least, we would divide both sides by 14. And 14x divided by 14 is x. And 7 divided by 14 is 1/2. You're welcome. Any other questions on these two here? We good with these two here? Okay. Questions on 42 or 43? So which one do you want to look at, Becky? Another one of these? Okay. 44 or 45? 44. So when we look at this here, we have a variable in the exponent. So the first thing we really need to do is to get whatever the base is. So here it's base e. We need to get e by itself first. And the first thing we can do to get e by itself is we're going to subtract 9 first. Because we really want to get e by itself, and subtraction and addition are going to be the easiest ones to do first. Because if we divide it by 6 first, we would have to divide by our 6e to the 2x plus 1, the 9, and the 15. We have to divide by all 3. And the 15 and the 9 are not divisible by 6, but when we do subtract them, we would get a whole number. Yes, now we will divide by 6, which would leave us with e to the 2x plus 1 is equal to 1. Then we would take the natural log of both sides, and the 2x plus 1 would move out front, and this would cancel, leaving us with just 2x plus 1 is equal to ln of 1. Yes. Because now we need to solve for the value of x. So 2x is equal to the natural log of 1 minus 1. Then we would divide by 2. Which would tell us x is equal to the natural log of 1 minus 1 divided by 2. Do y'all agree with negative 1/2? What's the natural log of 1? It's 0. The log, or natural log of 1, log doesn't matter what the base is, and the natural log of 1 is always 0. ln of 1 is 0. The log of 1, whatever the base is always going to be 0. So that's it. Any other questions on these two here? You feel good with these two? Questions on 46 or 47? Okay. Questions on 47? So we go to 47, because since both of them have natural logs, we just set what's inside equal and solve for the value of x. Questions on 48 or 49? Is there one of those that y'all want to see? No? 49. Since both of them have log, the same log on either side, we're really saying that now the first thing I would do is be to subtract 12x from both sides. Yep, divide by negative 9. And that's it. What'd you do? Did you use same thing? That's not wrong. That's just doing it a different way. As you move the 9 over, then the 3x. We just moved the 12x over. So it's the same process because you ended up getting negative, or 9x equals 9, divided by 9, and we get there. Just a change in sign. Exact same process, just looks different. Because the logs are the exact same, we set them equal to each other. Now I notice that since it does have an x squared, we need everything on the same side. So I will add x to both sides. Negative x plus x is 0. Well, both of these cancel out, giving me x squared minus 6 is equal to 0. Now, since we don't have a middle term, we can use the square root method, which means we can get the term that is squared by itself and get the number on the other side. So we can add 6 to both sides, which tells me that x squared is equal to 6. And then what would we do? So x is equal to plus or minus the square root of 6. Any questions on this so far? Now we do need to check it, because we do have a positive and negative case to see which one works. So any questions before we start checking? Okay. So let's check the positive case first. Log base 2 of the square root of 6 squared minus the square root of 6 minus 6 is equal to log base 2 of negative square root 6. So over here, square root of 6 squared is 6 minus the square root of 6 minus 6 equals log base 2 of the negative square root of 6. Can't have a negative in the log, so that doesn't work. Because even over here, we would still get log base 2. Those would cancel negative square root of 6. So the positive square root of 6 does not work. So let's check the negative square root of 6. Log base 2 of the negative square root of 6 squared minus negative square root of 6 minus 6 equals log base 2 of negative square root of 6. Well, the negative, when I square it, it becomes square root of 6 squared is just 6. Negative and negative make a positive square root of 6 minus 6. Negative and negative gives me a positive square root of 6. Well, 6 minus 6 is 0, so I get log base 2 of the square root of 6 is equal to log base 2 of the square root of 6. It works. So our solution is that x is equal to negative square root of 6. And I intentionally put that in there just to drive home the point that the value of our answer does not have to be positive. Because here it worked out that we could actually have negative answers that do work. Because again, when we plug it back in, what we have left cannot be negative. Not what we're plugging in cannot be negative. Because when we plugged in our negative square root of 6, all that's left over is a positive and a positive. We have positive numbers left over. Questions on this here? Questions on 51 or 52? Okay. To get rid of the natural log, because there's nothing else with it, because these would cancel out, leaving us with 6x minus 2 is equal to e to the 7th. Yes. Change one thing. Yep. I know 100%. I'm 100% certain you would have put plus 2. You knew what to do. And then divide both sides by 6, which tells us x is equal to e to the 7th plus 2 divided by 6. And I would make sure to write this out, e to the 7th plus 2 divided by 6 when you're taking the test tomorrow, and then go on and write the answer. And I want you to write this out just on the off chance, for some reason, you put everything in the exponent instead of actually writing it out. You put e to the 7 plus 2 divided by 6 instead of e to the 7th plus 2 divided by 6 as we have it here. You end up putting it in as, because you're not paying attention to how it's writing, hit enter, put that answer down. I will know, okay, you got the right thing, but probably you typed it in wrong. I'll be able to give you the points for it. Any questions on 51 or 52? Yeah. Did anybody figure out what the answer for this was? Either that or you can look at the back. 52. 183.106. There we go. So any questions on 51? Are we good with 51? Questions on 53 or 54? 54 is the log by itself. What's with it? Minus 4, it's not inside, is it? So the first thing we need to do is actually get the natural log by itself by subtracting 4 from both sides. Or adding 4 to both sides. Because it's being subtracted, so we would do the opposite in adding.
And then when we put it to E.
Yes. Now that the natural log is by itself, we really don't consider what's inside. We'll worry about it later. But there's nothing outside of that log. And once we get everything away from it, then we can apply E to both sides, because those will cancel, leaving me with 6x is equal to E to the, yep. And this number is going to be pretty big. $29,747,050 and 16 hundredths. Big number. Questions on this here? So for the other one, what would we put both sides to? We wouldn't use E, we would use, for 53, we would use 9, because the base is 9. So whatever the base is, once we get that log by itself, we apply it to both sides to simplify the log out. So are there any questions on 51 through 54? We good with these here? You don't need the commas if you don't want to put them. I just put them there so I could read the number out. Questions on 55 or 56? So when we expanded the log or condensed the logs, with the plus, I could rewrite two logs that are added together as one log with what? What's inside being multiplied. Now what can we do next? Those will simplify. And we can distribute here in a minute because we're going to have to. And 5 squared is 25. So we'd have x squared plus x plus 4x plus 4. And yes, you could go on and say 5x if you want. If you can see that, how that works out, go on and do that. Because you can go on and replace and rewrite it as what we'll end up doing here as x squared plus 5x plus 4 is equal to 25. Other way. So we wouldn't minus 4 from both sides, but we will minus 25 from both sides. Because since this is a quadratic, we do want it equal to 0. Now this one here will factor. I know some of them on the review sheet weren't factorable, so you had to use the quadratic formula, but this one here will. So we'll have x and x, plus and minus, because the 21 is negative. And no, it won't, because I was really hoping it would. Because this won't factor. Let's see here, square root 25 minus 4 times a. Yep, just like I thought. We're going to have to use the quadratic formula. Because this won't factor. Because 3 and 7 would be the closest thing we get, because 1 and 21, 3 and 7. 1 and 21 won't work, and 7 minus 3 is 4, not 5. Still close. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if we type 5 squared minus 4 times 1 times negative 21 into the calculator, we'll get 109. Now, it did ask for answers rounded to 3 decimal places. .720. And negative 7.720. So these are our 2 answers. Now, when we look back and check it to see which one works, well, negative 7 on both of these will cause us to have a negative inside the log. It does not work. But for us, the 2.720 or 2.72 will work because we're adding it to 4 and adding it to 1. It'll just make it a bigger positive number. And that's all we need to do for this here. Any questions on this one here? Morning. Any questions on 56? Yeah. So again, just like with the last one, because these 2 are being added together, we can rewrite it as multiplication. X times x plus 2 is equal to 3. And again, just like on the last one, we can put both sides to the base of 2. We have x times x plus 2 is equal to, well, 2 to the third is 8. Questions on this so far? Well, we can distribute the x. X times x would give us x squared plus 2x equals 8. Now, because this is a quadratic, we want this equal to 0. So we'll subtract 8. X squared plus 2x minus 8 is equal to 0. Any questions on how we got to this point here? We good with getting to here? So let's see if this will factor. So we know we'll have x and x, plus and minus because the 8 is negative. And what factors would work? 2 and 4. And the 4 would have to be positive. Okay, since the middle term is positive. So we'd have x plus 4 is equal to 0 and x minus 2 is equal to 0. So we can solve each one of these here. Minus 4 tells me x is equal to negative 4. Here we would add 2 to both sides. Tell me x is equal to 2. Now, if we look back at the original problem, we had log of x and log of x minus 2. Well, negative 4 will not work in either one of those because negative 4 does not work. Huh? For here? Mm-hmm. Oh, sorry, I didn't even notice that. Yes, thank you. That'll make things a little bit different because I was looking down, I'm like, that still doesn't work. Mm-hmm. Yep, I had the wrong sign written the whole time, which would make the problem a little bit different. All of this. Well, we would get the same numbers, but the signs are going to be different. Mm-hmm. Because we should have x minus 2, x plus 2, and x minus 4 is equal to 0. Now, x equals 4 does work, and our negative 2 would not. And interestingly enough, if it was actually x plus 2 in the other one, it would have been no solutions. Well, especially if it's minus 2. Actually, it would have given us a true solution. But, yeah, I just noticed that at the end. Yep. Does anybody have any questions on that, even with that switch? Does that kind of make sense? The process doesn't change, even though the sign did. Questions on this here? You good with that there? You with that hiccup? Yes. Questions on 57 or 58? We good with it? Yep. Without an equal sign. So we don't want to look at 57 or 58? Okay. 59 or 60? 60. So when we look at this here, we really want to get the log by itself first. So what's the first thing we can do? Divide both sides by 5. Which will tell us that log base 7 of 4x is greater than or equal to 32. Now what can we do next? Because these would cancel. Tell me that log, not log, because we just canceled it out. It would just be 4x is greater than or equal to 7 to the 32nd. And then what would we do next? Divide by 4. And x is greater than or equal to 7 to the 32nd power divided by 4. Now, because that does not include negatives, that is our answer. That's all we have to do for this here.
So if it did include a negative, we have to put it on the opposite side, right?
Well, then we would need to find the restrictions. We would need to see what would make 4x, what's inside the log, be 0, set it greater than that, and solve for that there. So let's look at 59. Any questions on 60? Because I'll take that there because it's such a huge number, we'll leave it be. Now 59, we'll want to subtract 7 first to get at the natural log by itself. So you have 6 ln of x is less than 53. Then we would need to divide both sides by 6, which tells me ln of x is less than 53 divided by 6. Now, I left it as 53 divided by 6 because I know 53 is not divisible by 6. For it to be divisible by 6, it has to be divisible by both 2 and 3. And I can already see 53 is not divisible by 2. Doesn't matter about the 3. So it's not divisible by 6 because it has to be divisible by both. Now, the next thing we can do is apply e to both sides to get those two cancel, which tells me x is less than e to the 53 divided by 6. Now again, that's going to be a huge number. But since this does include negatives, because negative 1 is going to be less than whatever the heck e to the 53 divided by 6 is. So we do need to check and see what would make what's inside the logarithm x be less than 0. So we can set it up as x has to be not less than, x has to be greater than 0. I didn't like that dot being there. Because whatever is inside the logarithm cannot be 0, it has to be greater than 0. And once we get whatever is inside the logarithm set greater than 0, then we solve for the value of x. Okay, we're done. Huh? So 59, x 0 is greater than x is, so 0 is less than x is less than e to the 53 divided by 6. Any questions on this here? We good with that one? Questions on 61 or 62? Yes. Okay. 62. So we want to get the variable, and especially the base, with the variable by itself. So we have 3. Is the 3 by itself? Because is there anything being multiplied by the 3? Is anything multiplying by our base of 3? Is anything being added to the base of 3? No. The only thing that's really with the base of 3 is the 4x minus 5, but it's all up in the exponent. Because we don't really consider anything being added or multiplied, anything with the 3, that's in the exponent. Because if there's something added to it, like for 61, the negative 5, minusing 5, then we would move it. But since this is by itself, I can go on and apply log base 3 to both sides, because these would cancel. So we have this here. So what can we do next? Yes, we can add 5 to both sides, which tells us 4x is greater than log base 3 of 108 plus 5. But I feel like this shouldn't be too big of a number. Huh? 220? 2.315. So anything greater than 2.315 will be an answer, will be the correct answer. Any questions on this one here? Any questions on these two here? So when we look at these here, especially when we're dealing with exponents, can I have a negative inside of the exponent? Well, yeah. Yeah, because if we have a negative exponent, we move the base from the numerator to the denominator, or denominator to the numerator, and it makes it positive. So I can have a negative number inside the exponent. So like this one we just did, if we end up getting a negative answer, that's fine. We don't have to check for any restrictions for making it greater than 0. It's only with logarithms and natural logs that we have to check those values or make sure that our solutions does not include negatives. Any questions on this one here? Any questions on 63 or 64? Are we good with these two here? Well, that is the end of the review sheet.